Right now, as you sit perfectly still, you might feel entirely stationary, but you are secretly traveling at the maximum speed the universe allows. In 1905, Albert Einstein discovered that space and time aren't separate stages. They are permanently locked together into one single four-dimensional fabric called space-time. And because they are locked together, there is a universal rule that applies to you, to me, and to everything else. We all possess a constant combined speed through this fabric. Because you aren't currently moving through physical space, the universe funnels 100% of your cosmic speed into traveling forward through time. You are hurtling into the future as fast as physically possible. Think of this speed limit like a fixed allowance. This gauge is split between a space axis and a time axis. Sitting still, all allowance is spent on time. But when you walk, you divert a fraction of your budget into space. Because your total allowance can never change, spending part of your budget on space means your speed traveling through time must mathematically slow down. Moving through physical space inherently costs you time. This trade-off is an unavoidable rule of reality, known as time dilation. Scientists have turned this theory into an engineered reality by testing it with commercial airlines. Researchers took highly precise atomic clocks and flew them around the world on passenger jets. When those planes landed, the clocks that traveled in the air were younger than identical clocks left completely still on the ground. We see this same effect every day in giant particle accelerators. When scientists spin particles up to incredibly high speeds, those moving particles age much slower than stationary ones. Even the GPS satellites orbiting Earth have to constantly correct for this time-bending effect. If they didn't adjust their internal clocks to match the slower passage of time in orbit, the navigation app on your phone would fail entirely within a day. Even everyday physical movement through space alters the passage of time for that moving object. To see what happens at extreme speeds, we can look high into the upper atmosphere. When cosmic rays hit gas molecules, they create fast-moving, highly unstable particles called muons. This scaled map shows the 15-kilometer drop from the upper atmosphere to the ground. Muons only live for about 2 microseconds. Even traveling at nearly the speed of light, this timer shows they shouldn't survive long enough to cross that distance before vanishing. Yet detectors on the ground find them constantly. Because they travel at over 99% the speed of light, their time slows down drastically. From the muon's perspective, its timer barely ticks, and the actual physical space it has to travel collapses down to just 600 meters. As an object approaches the speed limit of the universe, the physical space around it collapses, and its internal clock grinds to a near halt. Which leads us to the ultimate question. What happens to a photon, a single particle of light, the very entity that defines the maximum speed limit of the universe? Let's bring back our cosmic allowance diagram. Because light travels exactly at the maximum speed limit, it spends 100% of its budget on the space axis. This slams the time axis all the way down to zero. Mathematically, the time interval experienced by a photon crashes to zero. It experiences no time at all. The exact same thing happens to physical distance. Because it is moving at the absolute maximum limit, the entire spatial dimension collapses into a zero-dimensional point for the photon. From the perspective of light itself, the ideas of traveling speed, physical distance, and ticking clocks are non-existent illusions. Let's apply this to a real-world cosmic journey. Imagine a single photon emitted by a star in a distant galaxy, 13 billion light-years away from Earth. From our human perspective, we watch that light particle take 13 billion years to cross a massive cosmic void before finally striking the golden mirrors of a telescope. But from the photon's perspective, because its time and space both equal zero, it is emitted by that distant star and immediately absorbed by the telescope in one single instantaneous flash. Light never actually moves. It is a timeless bridge. When you look up at the night sky, you aren't waiting for ancient light to reach you. Your eye is directly touching a star across a universe where light never traveled at all.